Hello subscribers, welcome to Stematics tutorial. Today we are going to see the very important answer relationship between central and non-central moments. Before going to the video, those who didn't subscribe yet, please subscribe, like and share the video. Relationship between central and non-central moments. This question is very important long answer, and this can also be asked in another way like express central moments in terms of non-central moments. So that time you can write this answer. So let us start our derivation. Let us consider the rth central moment and by using that we will formulate the non-central moment. So let us write that first. Okay. Now the rth central moment of x about mean is given by mu r equal to 1 by capital N summation fi into xi minus x bar whole power r. So in that this is our rth central moment about mean. Now here in bracket we are having xi minus x bar. Let us add and subtract a in that bracket. So add a is some arbitrary point. Let us assume that add and subtract capital A. So what it becomes mu r equal to 1 by n summation fi xi minus a plus a minus x bar whole power r I have taken. Now let this xi minus a and a minus x bar will express in another terms. Let di equal to xi minus a and minus mu 1 dash equal to a minus x bar. Let us consider that. Now substitute these terms in this equation. So now mu r equal to 1 by n summation fi open the bracket. In place of xi minus a, what we have to substitute? We have to substitute di, and in place of a minus x bar minus mu 1 dash. Let us substitute that mu 1 dash whole power r. So this is the formula we have got after substituting these values. Now we will use the binomial expansion in order to expand this term. So by binomial expansion, so we have a formula x minus a whole power n. For x minus a and x plus a we have formula. So x minus a equal to nc0 x power n a power 0 minus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a power 2 up to so on. Let us write till four values we will write this formula because we have the 4 central moments, right? 4 central and 4 non-central moments. So in order to derive that, we will write till 4 nc3 x power n minus 3 a power 3 plus nc4 x power n minus 4 a power 4 plus so on. 1 plus 1 alternative symbols, plus minus you will get here, plus again minus so on. I don't know the symbol here for the last term x minus 1 whole power n ncn x power 0 a power n. So this is the binomial expansion formula for x minus a whole power n. So how would you remember this formula? Means take down this n x minus a whole power n. So nc0, its derivation expansion starts from 0 only. So nc0 x power n, the highest power is here n. So x power n and a power 0. If we add these powers, we must get equal to n. So n plus 0 is n. Next reduce this x term power and increase this a power. So that what you'll get in the next value, 0 is finished, n is common, c 1. After 0, 1 you'll get x power n minus 1. You have to reduce I told now by 1 into a power, this you have to increase 1. If you add up these two powers, what you'll get? N minus 1 plus 1. 1 gets cancelled, again you got n. So like that you have to remember the formula. As we are using x minus a whole power n, we will get the symbols like positive signs like plus minus. Alternatively, you'll get positives and negative symbols. So same formula you can apply to this now. D minus mu 1 dash whole power r. So in place of dx, you can substitute di. In place of a, you can substitute mu 1 dash, and in place of n, you can substitute r. Now by using this formula, the above formula changes to what? Let us see that. So that implies mu r equal to 1 by, you can write here if you want, let di equal to, what we are taking, x equal to di. Now I'll write here, let di equal x equal to di, comma a equal to mu 1 dash n equal to r. So you can substitute in this formula. Now that implies mu r equal to 1 by n summation fi is common. So after that bracket starts. So I'll start bracket now. Bracket d minus mu 1 dash whole power r. By using this formula changes to now, in place of n what I have to take? R. So r c0 and x place low, in x place I have to substitute di. So di whole power what r? N means we have to take r. So di power r a power 0. What is a here now? Mu 1 dash. Mu 1 dash whole power 0. Next minus. We have minus nc1 means rc1 x power n minus 1. In place of x, di we are taking. So di power r minus 1 into a mu 1 dash. Mu 1 dash power 1. Next, after this we have second term, third term plus rc2 x place lo in x place di whole power n minus 2. N minus 2 means r minus 2 into mu 1 dash whole square plus again minus we have minus rc3 x means di whole power r minus 3. A means mu 1 dash. So mu 1 dash whole power 3 again plus. Next we are having fifth term nc4. So rc4 next x power n minus 1 di power r minus 4 into mu 1 dash whole power 4 plus so on up to last term minus 1 whole power r into rcr and x power 0 means di power 0 into a power n. A means mu 1 dash whole power r. So this is the answer we got finally, and let us solve further in order to get a non-central moments. So that implies mu r equal to 1 by n summation fi into rc naught value is what? 1. So 1 into di whole power r mu 1 dash whole power 0. Anything power 0 is 1. So you can substitute here 1 minus rc1 value is r and di power r minus 1 into mu 1 dash whole power 1 as it is plus rc2 and di whole power r minus 2 mu 1 dash whole square minus rc3 di whole power r minus 3 mu 1 dash whole cube plus rc4 di whole power r minus 4 mu 1 dash power 4 plus so on minus 1 whole power r rcr into di power 0. Anything power 0 is 1 into mu 1 dash whole power r is as it is. So this is completed. So what did we substitute? Since anything power 0 is 1. So let us substitute. Let a power 0 equal to 1. Since a power 0 equal to 1 and rc0 equal to 1. Next rc1 equal to r. Still anything else? So this we have did here. Next. Now multiply 1 by n summation fi to each term. So that what we'll get, we'll see now. So mu r equal to 1 by n summation fi into 1 into di whole power r into di into 1 is di power r minus r 1 by n summation into this whole term. So r is a constant, I'll bring outside r 1 by n summation fi di power r minus 1 into mu 1 dash whole power 1 plus again rc2 and this whole term into this one. So 1 by n summation fi di power r minus 2 mu 1 dash whole square and rc2 I am writing in front rc2. Next we have minus sign minus rc3 again multiply with this 1 by n summation fi di whole power r minus 3 mu 1 dash whole cube. Next plus rc4 1 by n summation fi di power r minus 4 mu 1 dash whole power 4 plus so on minus 1 whole power r rcr 1 by n summation fi di term is not there mu 1 dash whole power r. So this is the formula we got at the end. Now from non-central moment, now what we have to do, our problem is, or our theorem is, convert a relationship between central and non-central moments. So we have taken out the central moments. Now we are converting the central moments into non-central moments. So non-central moments formula, what is non-central moments? How we denote the non-central moment? Mu r dash equal to, we denote the central moments with mu r. Mu r equal to 1 by n summation xi minus x bar whole power r. In case of non-central moments, we denote mu r dash equal to 1 by n summation fi di. So from non-central moments, we have mu r dash equal to 1 by n summation fi di power r. Now wherever this 1 by n summation fi di whole power r is there, we are going to substitute mu r dash. So that implies mu r equal to, so first formula what we have, 1 by n summation fi di power r. So you can replace that with mu r dash. This is exactly the formula mu r dash. So we can substitute here mu r dash minus r as it is 1 by n summation fi di whole power r minus 1. So here if we have r, is coming to the non-central moments formula, mu r dash equal to 1 by n summation fi di power r. If you have here r, then di power is r. If you have here r minus 1, then di power changes to r minus 1. If it is r minus 2, then di changes to di power changes to r minus 2, di whole power r minus 2. So now what is this formula? This formula becomes 1 by n summation fi di whole power r minus 1 becomes now mu r minus 1 dash into mu 1 dash whole power 1 is mu 1 dash plus rc2. Now 1 by n summation fi di whole power r minus 2 becomes what? Mu r minus 2. Mu r minus 2 dash. Mu r minus 2 dash into mu 1 dash whole square minus rc3, and 1 by n summation fi di power r minus 3 becomes mu r minus 3 dash into mu 1 dash whole cube plus rc4. 1 by n summation di power r minus 4 becomes mu r minus 4 dash mu 1 dash whole power 4 plus so on, and the last term minus 1 whole power r rcr. So 1 by n fi di is not there here, so I'll write as it is 1 by n, and summation fi, summation of all the frequencies becomes capital N. We have learnt in mean median mode. So in case of measures of central tendency, we have learned that total of all the frequencies become capital N. So 1 by n into capital N and mu 1 dash whole power r. So now this n and this n gets cancelled. So you will be left over with minus 1 whole power rcr, or minus 1 whole power r into rcr into mu 1 dash whole power r. So this rcr also becomes 1. You no need to write this one again. So rc minus 1 whole power r into 1 by n summation fi becomes capital N mu 1 dash whole power r. Finally, we have got mu r equal to mu r dash minus r mu r minus 1 dash into mu 1 dash plus rc2 mu r minus 2 dash into mu 1 dash whole square minus rc3 into mu r minus 3 dash into mu 1 dash whole cube plus rc4 mu r minus 4 dash into mu 1 dash whole power 4 plus so on, minus 1 whole power r into 1 by n, 1 this gets cancelled. So minus 1 whole power r into mu 1 dash whole power r. Next. So this is the final formula we have got from central moments. From this you can observe that all the left hand side value, only one we have, that is our central moment, and on the right hand side we are having all the mu's with dashes, which are called non-central moments. Now we have to express this central moments in terms of non-central moments, right? So substitute r equal to 1, 2, 3 up to 4 values, because we need up to 4 central moments and 4 non-central moments, right? So put r equal to 1. Now the formula changes to what we will see. Put r equal to 1 implies mu r equal to 1. So this becomes mu 1 equal to mu r dash. So mu 1 dash minus r. R means 1 into mu 1 minus 1 dash, because r minus 1 dash into mu 1 dash plus rc2 means 1c2. 1c2. This cannot be, we cannot take this value because the r value is less than this 2 value. So this is not possible actually, and also here you are going to get mu 1 minus 2 dash. So that means mu minus 1 moments cannot be negative. Mu minus 1 dash, mu minus 2 dash, like that you won't get. So we will stop till here. Now mu 1 equal to mu 1 dash minus mu 0 dash into mu 1 dash. So this becomes like mu 1 dash minus mu 0 dash is, you already know that in moments mu 0 dash equal to 1. So this becomes mu 1 dash. Mu 1 dash minus mu 1 dash is 0. Therefore mu 1 equal to 0. Now r equal to 1 is finished. Let us substitute r equal to 2. If we substitute r equal to 2, this formula changes to mu r means mu 2 equal to mu r dash. That means mu 2 dash minus r means 2 mu 2 minus 1 dash into mu 1 dash plus 2c2 mu 2 minus 2 dash into mu 1 dash whole square minus 2c3. This is not possible, so we are going to stop till here, and this becomes mu 2 dash minus 2 mu 1 dash into mu 1 dash plus 2c2 means 1 rcr ncn, like that. If both here n value and r value are both are equal, means we will get 1 into mu 0 dash into mu 1 dash whole square. So finally we got mu 2 dash minus mu 1 dash into mu 1 dash. This becomes mu 1 dash whole square plus 1 into 1, since mu 0 dash equal to 1, so 1 into 1 is 1, and into mu 1 dash whole square. Mu 2 equal to mu 2 dash minus 2 mu 1 dash whole square plus mu 1 dash whole square is minus mu 1 dash whole square. So this is our central moment mu 2 in terms of non-central moments mu 2 dash and mu 1 dash. Now r equal to 2 is finished. Now we have to substitute r equal to 3. For r equal to 3, we get like mu3 equal to mu3 dash minus 3 into mu 2 3 minus 1 dash into mu1 dash plus rc2 means 3c2 mu r minus 2 dash, that is 3 minus 2 dash into mu1 dash whole square minus 3c3, rc3 means 3c3 mu 3 minus 3 dash into mu1 dash whole cube plus rc4, that means 3c4. It is not possible, so we have to stop till here only. So we have got this after substitution. So mu3 dash minus 3 mu2 dash, right? 3 minus 1 is 2, so 3 mu2 dash mu1 dash plus 3c2. 3c2 is equal to n factorial by r factorial into n minus r factorial. So this is our n and this is our r. So 2 factorial into 3 minus 2 factorial. 3 factorial expansion is 3 into 2 into 1 divided by 2 factorial. 2 into 1 into 3 minus 2 factorial is 1 factorial. 2 and 2 gets cancelled, so it is equal to 3. So we can substitute here directly. 3c2 is 3 mu1 dash into mu1 dash whole square minus 3c3. I told you already RCR and CR is equal to 1. If both are same, n and r values are same, say 1 into mu0 dash into mu1 dash whole cube. mu0 dash is 1. So mu3 dash minus 3 mu2 dash mu1 dash plus 3 mu1 dash whole cube minus mu1 dash whole cube, since mu0 dash equal to 1. Therefore mu3 is a mu3 dash minus 3 mu2 dash mu1 dash. We have one more thing, right? Mu3 equal to, so mu3 equal to mu3 dash minus 3 mu2 dash mu1 dash. 3 minus 1 is 2 mu1 dash whole cube. This is the final formula we have got from the formula above. Now we have to substitute for r equal to 4, because we need to get 4 central moments and 4 non-central moments, right? So 4 central moments, so r equal to 4, and the formula changes to, for r equal to 4, this become mu4 equal to mu4 dash minus 4 mu 4 minus 1 dash mu1 dash plus 4c2 mu 4 minus 2 dash mu1 dash whole square minus 4c3 mu 4 minus 3 dash mu1 dash whole cube, and plus 4c4 mu 4 minus 4 dash into mu1 dash whole power 4. And after that it is not possible, we have to take till there. So this is the formula we have got after substituting r equal to 4. Now mu4 dash minus 4 mu3 dash mu1 dash plus 4c2. 4c2 becomes what we will see here. 4c2 equal to 4 factorial by 2 factorial into 4 minus 2 factorial. So 4 can be written as 4 factorial, 3 into 2 into 1 divided by 2 into 2 minus 2 factorial is 2. 2 gets cancelled to 1 are 2 2s are, so 2 3 are 6. So 4c2 is 6 mu 2 dash into mu1 dash whole square minus 4c3. 4c3 is obviously 4 only, but that also will do here. 4c3 equal to 4 factorial by 3 factorial into 4 minus. So 4c3 is, here I have done, it is equal to 4 factorial by 3 factorial into 4 minus 3 factorial. 4 into 3 into 2 divided by 3 factorial is 3 into 2. 4 minus 3 factorial is 1. So 3 2 gets cancelled, and leftover is 4. C3 is 4 now into mu1 dash whole cube plus 4c4 is 1 into mu0 dash into mu1 dash whole power 4. This is equal to mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash whole square minus 4 mu1 dash whole power 4. Mu0 dash is 1, so mu1 dash whole power 4, since mu0 dash equal to 1. So finally, therefore mu4 equal to mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash whole square minus 4 plus 3 minus 4 plus 1 is minus 3 mu1 dash whole power 4. So by this we have completed all the 4 central moments in terms of non-central moments. You can observe here, in 4 central moments, all the left side are central moments and right side are non-central moments. So if you have any doubts, you can comment in the comment section.